I have this sort of in two parts: things to exclude, failed ideas, and things to include. And so let's start with some of the things to exclude. The theory that space and time are continuous with its miracles. Let's take as an example of this the various field theories out there, such as, for example, gravity. People will talk about in their use of continuous space and time model the fact that there's a gravitational potential at every single point in space. Well, for any particular volume, there's an infinite number of points. Where is the miracle here? Well, in order for there to be in existence, in some kind of a physical existence, a gravitational potential at every one of those infinite number of points, you're going to have some device at every single point, which is miraculous. It's going to have, I guess, sensors of some sort to sense the presence of material objects that are the source of this gravitational potential. It's going to have some kind of fantastic, incredible computational power to keep all of this incoming data updated to then give you this scalar value of what the potential is at that point, or a vector value, even more complicated in terms of the gradient of such a potential, if you want to talk about that. So that's what I'm talking about here. The theory that
So you're objecting to field theory? Is that what you're saying? I'm not quite sure.
In the context of the model that space and time are continuous, yes. Binary mechanics does postulate electromagnetic fields, an electric field and a magnetic field, which are the M and L type quanta. So I'm not rejecting the fact that there are fields. I'm rejecting how or what the physical mechanism is to determine what those fields are at an infinite number of points in any spatial volume. Additional spatial dimensions beyond 3D is, I think, a failed idea. For example, in the work in binary mechanics, with just 3 spatial dimensions, we're able to accomplish quite a lot. So where do we have more than 3D? Well, perhaps the most common examples that everyone is aware of are special relativity and general relativity, where time is used, or they attempt to use time as a 4th spatial dimension. Most people, not everybody, okay, but most people believe that there's this thing we call the arrow of time, so that there's only one way that we can move in time. That's what the arrow of time is talking about, I believe. And so that when we attempt to use time as a 4th spatial dimension, it's sort of a crippled 4th spatial dimension because it can only move in one direction. Whereas the ordinary spatial dimensions, X, Y, and Z, as we normally call them, in 3D, you can move either direction. And so that time is sort of a lame 4th dimension in those cases of special relativity. A third point, notion that universe has a beginning time. I would call that the biblical approach to cosmology. Like Genesis, we have the time when everything started and God said this and God said that. And it all has a beginning. Of course, the Big Bang has this beginning time idea. I think that this notion just needs to be sort of set aside. Yeah, I mean, this is just something we can't even know at this point. We just don't have the knowledge or footing in order to really establish that such a thing as a beginning time of the universe. It's sort of a kindergarten view. It's a little bit a childish way to look at things. Moving on, a fourth idea of things to exclude. Postulates, whether they're new particles, processes, or dimensions, which I covered above, which are really not falsifiable. postulates which can't be falsified should be excluded, I believe. Next, exclude conservation laws which postulated events violate. We've heard a lot about conservation of angular momentum as being something which is conserved. But this idea of things sort of exploding or extruding outward from a center violates that law, because whatever energy was in angular momentum, some of that is converted to linear momentum. That's how rockets get off the planet Earth. In order to get something up and away from the center, you've got to add some linear momentum. And if the energy was all in angular momentum, it means that some of that was converted to linear momentum, I would think. Okay, let's move on to do not use unexplained measurements. For example, the speed of light, the electric charge E, Planck's constant H, etc., and others, like we've heard about the Rydberg constant, another unexplained measurement, wrongly called fundamental constants as input parameters. You're getting to pay dirt when you have none of these as input parameters because they're unexplained measurements. And until those are accounted for, they can't be used as input parameters, else you've really passed the whole stage. It's like saying, I'm going to do calculus before I know how to do algebra. Explaining these measurements is like the algebra, but what people want to do is skip that explanation, skip that task, which is on the table for scientists to understand, and go straight to calculus. Well, it ain't going to work. And the fact that that does not work, I think, is borne out by the data. The fact that all of those theories, which use these unexplained measurements as input parameters, are failing. Take the Standard Model, for example. It uses a whole boatload of these unexplained measurements as input parameters, somewhere around 20 of them, 19 or 20 the last time I looked. And yet the mainstream media is going to tell us that this is the quote unquote standard model. Standard meaning it's what everyone really accepts. But I can't find a single physicist that actually accepts the standard model. There are none. Everybody criticizes it and says it's inadequate and needs to be updated. So most physicists are on my side on this particular issue, I believe. Moving down the list, exclude assertions that physical principles are different at microscopic and macroscopic scales. All the macroscopic scale type data is simply statistical analysis of events which occur at a more microscopic level. I think this is the lesson that physics has taught us. And so where there are assertions that actually we have a new physical principle at some cosmological level at a macroscopic scale, which doesn't occur at microscopic levels, I think that's a very questionable approach. And lastly, I think this is obvious, exclude logical contradictions among model components. Moving on, I sort of included this slide here as what you get when you fail to exclude the things that I just listed for you on the previous slide. So we could call this the side effects or adverse reactions. It's sort of like taking a medicine that has adverse reactions of conventional physics and cosmologies. There are contradictions, dualities, paradoxes, uncertainties, magic, miracles, suspension of disbelief. Many questions are not allowed. Equation collapse, Planck limits, which is a magical mystery tour because those Planck limits are in fact just a combination of unexplained measurements. And so they too are in the unexplained category. As a matter of fact, to hit the ball out of the park, we might say if you're including unexplained measurements in your theory or model, basically your theory or model is just more unexplained stuff. Of course, we want to include successful ideas.